Yeah, I would like to start with this great quote from the Dune novels. I don't know if anybody of you read the Dune novels or is familiar with the work of Frank Herbert. But if you read the novels, or there's now also a movie running, then you notice that there are no computers. And of course, for Frank Herbert, this was a trope not to write about computers. But also there's a philosophy behind it, which is really interesting. The reason there are no computers is that at one point in human history there will be a holy war against computers. And then, of course, when you think about holy war against computers, you think, oh, there's like machines that are going to kill us. But when you read the books, you find out that it actually was way more subtle. And that at one point in human history, humans get fed up by the way computers are shaping them. And I think this is a really interesting thing, because Frank Herbert, he wrote this in the 60s. And yeah, it's like he was really like ahead of his time. And what does that have to do with my work, or the things I'm interested in? Because of course I'm a programmer, I work with computers all day. But I like to work with computers and enhance the human experience. And computers don't interest me that much, actually. So, in this presentation, I will talk a little bit about who I am, and what we do with NAP, which is the open source framework that we develop, why we develop it. I will showcase some of our projects, I'll talk about our reason to be, and share some inspiration. So, who am I? This is me from 20 years ago, when I was much more handsome. And I started programming because I wanted to make an interface for myself to make music. And I was really annoyed by electronic music performances at that time. Because they were really boring. So I really like the music, I really like electronic music, so I would go out to a club and just really enjoy it. But the performance value of somebody behind a laptop or behind a DJ turntables even is minimal. And it's already like a sign of computers like dumbing down the human experience. So I really wanted to make something that would make me able to translate my physical emotion and expression back into the music. And this photo is really nice, because this is exactly what I would like to see in an electronic performance, is somebody interacting with the MC and the crowd, and somebody who can actually use its own body to make music. So this was my introduction into programming, because I needed to make it myself, and this really got me into it. Afterwards, I got the idea in my head that I needed a serious job, so I started to work at a game company as a game developer, but we were mainly focused on making installations. So I did this for quite some time. This is one of my installations that I built. Afterwards, around 2016, like virtual reality became a big thing. And I was like, okay, I'm gonna ride the bandwagon and be a freelance virtual reality developer. But I actually got really depressed after 4 years, because I don't find virtual reality that interesting. Because it's not like, I don't think it really enhances our like human experience. So after a while, I got in contact with Koen Clusters, and he says, hey, would you like to come work with us? I really like your work. I'm building an own open source framework, which we use to make physical installations and products. And I was like, yeah, maybe it's a good step just to step away from also proprietary frameworks, proprietary software, and go back into the nuts and bolts of software development. Because I was also like really experiencing, not experiencing too much joy anymore in making things, because I was getting dependent on frameworks that are already out there, and when I started programming, it was really like, okay, I can go down to the deepest level and make something from scratch. And somewhere along the way, when I was a game developer, that slowly started to, yeah, I started to work with other engines, which was nice, but also limited my creative abilities. So that's when I joined NAP Labs, which is a team of 4 developers. And what we do at NAP Labs is develop NAP, which is our open source framework, which I will show you. And we improve the interaction between human, machines, and the environment using our own technology. So we take pride in that we develop our own technology. And we open source it, so you can just go onto GitHub and use it yourself, try it out. We would very much encourage you to do so. And this is the team of current developers. We have many more developers in the past, but this is the current. These are the current 4 developers. We have Koen, who is the founder, our Lord and Savior, and then you have Stijn, who is like he developed the audio engine, and then you have me and Leslie, who are a software engineer. And basically, this is it. So we are 4 developers, and we are sustaining NAP at the moment. And the thing we share is like, okay, we're all really nerds, like we're really into programming, but we all have a background in either arts, music, and this is where we come from. So this is what we share. So we have people coming from the film VFX industry, from AAA game development, and music, art, and free party scene. So what do we do? What kind of projects do we make? Well, we automate shopping malls, like the upper left corner. You can see all the lighting is controlled by our software. We drive millions of LEDs at festivals, but we also make very small devices that you can take home. We control theater stages, kinetic light sculptures. Our engine is also the foundation of the 4D spatial sound engine, which is also used at the Spatial Sound Institute here. So I don't know if anybody of you knows it, but it's built with NAP. It's sorry? No, yeah. Well, we control lasers. We helped Helene with her artwork, but also retail installations. So a lot of, as you can see, a lot of different projects with a lot of different requirements, and we all do it with our own framework called NAP. So this is a list of our clients. We have Studio Drift, Philips, Groeneboom Group, all kinds of different companies that do different stuff, but they all require like high quality software with a creative edge on it. So these are also our current projects. So we do drone automation, swarming, wind simulations, projection mapping, museum automations, you name it. So yeah, what is exactly, how would you view NAP? Like if you are into coding, or you probably have worked with game engines, or maybe open frameworks or Cinder, and you have the visual programming languages. And NAP is really like positioned in the middle, and it's also aimed to make you able to make really professional products and installations that don't require maintenance and run for years. So yeah, this is one of our examples from the demo. So here you have the running application that's on the right, and then we also have an application editor which allows you to alter your content of your application and edit it. So what is NAP? It's a low overhead, open source, real-time control and visualization engine, which will allow you to build native applications to interact with the world around you. So we're not specifically focused on rendering, although we can do it, but our main focus is to allow you to build applications that work with sensors or yeah. So we use NAP to control high precision robotic, automate buildings, monitor things in your home, build immersive audiovisual installations, and or create new instruments, or visualize large data sets in 2D or 3D, or in any combination of the above. So, in short, we turn complex problems into user-friendly applications. So why should you use NAP? Or you can check it out. It's just very fast, it's free, and it scales really well. And this is also something that we're more recently interested in. Is that we want to break free from having these high requirements. So we really like to target small devices, and it scales really, really well. So you can run NAP on a render beast, render millions of particles and have a huge projection mapping installation, or you can say, hey, I'm just building a tiny application for the Raspberry Pi Zero without any rendering, and then you can just take the render module out of it and run it on a very small machine and really energy efficient. So what does it have? It has a Vulkan render engine, and it's also officially supported by Kronos Group. So we're on the side there. We're very proud of between all those big engines. It has an application editor for you to create and construct your application. It has a web portal to allow you to easily make a web interface for your installation or application. It has a timeline tool, so you can animate your robotics or whatever you want. It has a multi-channel audio engine. And we support many protocols out of the box. So if you, for example, would like to do something with open sound control or MIDI or whatever, you can just take the module and control your synthesizer or Lightning or whatever you like. So yeah, I think that's a small summary of what NAP is. And it's a lot, and we've been working on it now for almost 10 years in total. But I think I can best explain it by the projects, by some examples of the projects that we did. This is Ego. We were asked by Drift to think of a system to control this block, which is a block of 16 kilometers of razor thin wire, and it can take on different shapes. And it is made together with the Dutch opera, and it's used as an extra dancer on the stage. So this block moves with the dancers and is controlled in real time. So here you see a different picture where the block has a different shape. And I also have a movie that will hopefully make things clearer. So yeah, so what the requirements were is like, okay, Drift says, okay, we need real-time control over the movement of the complete block, but we also want to pre-visualize the block itself. So there's a whole physics simulation of the actual block, so you can make a show with the block and see it in your application without having the real block in there. So they can go and sit in a plane, make a show for the block, and then attach the hardware of the block on the computer, and it will be the same as the pre-visualized show that you made. It works with high precision industrial motors, like the EtherCAT motor, and that stuff is normally used to control car factories. So it's really a heavyweight protocol. And they required a timeline to draw the shows. And it runs on a low-end machine. So these are pretty difficult requirements. But I think it's best if I can just show you how it looks. But I'll have to put the mic down because otherwise I cannot control the computer. So yeah, this is to give you a sense of the application, but also like the versatility of NAP. And this is a tool. This is Napkin. This is our editor, which you can use to construct your application. So yeah, it looks really complex now, and I won't go into detail. But for example, it allows you, if they have a different installation somewhere else with different sizes, they can just live edit. Like, okay, the meter, the block is a little bit smaller, like this. And then it's instantly updated in the application. So they can have like many different instances and alter different like installations with this editor. And the simulation and the rendering instantly updates. So yeah, this project was a huge success, and afterwards they invited us or commissioned us to build a new software for the shylights that are running all over the world. Oh. And the shylight is this kinetic light that they make. So this is a lamp that goes in and out of the cocoon there, and yeah, it's a lamp, so you can control the brightness of the light as well. And to give you an idea, I have the showing on the Miami Basel. So yeah, they asked us to write a new software for the shylights because they had a lot of problems with the old version. So they had no real-time control over the lights, no real-time editing of shows, no pre-visualization of the complete setup. It did not scale very well, and it was very unstable, which resulted in very high maintenance cost. So the goal was to get it as good as Ego. So they wanted to make complete shows in real time and support like over 100 instances without the physical installation attached. So they wanted to be able just to make shows without having a shylight there all the time. So yeah, this is like a behind the scenes movie of the shylights where we controlled actually 40 shylights at once. And you get a sense of how they constructed like these huge sequences of 40 shylights together with audio. Yeah, I can show you a small demo of how it works. I'll have to put down the mic again, sorry. Yeah, so it works the same as with Echo. You can just live create your show and see the effect of the actions that you do in the sequencer in real time. And if I would have like the shylights available here, I could just plug them in, and you would instantly see the instances of the shylight move as well. And this like this plug and play mentality or feature is really helpful if you're working with artists or working with very specific requirements of the artist. So they can really make a lot of shows for different places using this software. And this is our hello. Yeah, this is one of our newest projects, which we initiate ourselves. Is we would like to move away a bit from commissioned work and also make work that is targeted for smaller devices and smaller systems that you can just bring home. So the idea behind this is that we make little coded artworks that you can buy and take home. And with this, we want to work with artists, and we can do the technical work, and together with the artists, we make like little pieces, that we sell in our shop. So this is because we want to move away a bit from only doing commissioned work or really large scale work, but really tiny products. So this is our latest product that we did together with Sigrid Calon, who is also a Dutch artist, and works a lot with typography, design, colors, and this is basically, it's a very simple thing. It's a clock, but it's you can tune it completely how you would like it, and you can see like the flow of time, not only in the numbers, but also in the way the coloring changes during the day. And our philosophy behind it is that we want to have like a 50-50 share between the artist and ourselves. So we really like put in evenly distributed work, yeah, we both really own it, and it's open design, so you can easily repair it. Each instance is unique. You cannot copy it. You cannot like copy the hardware and put it on a different machine. It's like really tied to bound to the hardware. It's completely built with our engine, of course, and we really don't like any phoning home or internet requirements. So you're safe. We don't listen to you. So yeah, why do I do all this stuff? It's a question that I ask myself a lot of times, because I can be this guy. I can just sit on in a nice island, work on I don't know, some crypto scam, or work for a fintech company, do something with blockchain that nobody understands. But I don't wanna do it. And I'm not interested in doing this stuff. But instead, I'm this guy, and I'm working day and night on our own engine, and everybody's telling me like, why do you do that? Why can't you like work with engine X or engine this? And I think like, there are a lot of problems with contemporary software development, which I would like to shortly talk about. And I think this really illustrates what's going on. There was a while back, there was this picture was going on to my LinkedIn about a pack of pears that is grown in Argentina, then it's like shipped to Thailand, and then it's consumed in the United States. And if you show that picture to a child, like intuitively, you know, like this is not okay. That there's something really, really broken in this, in the way this food is produced and distributed. Of course, when you look to it through a capitalistic lens, it makes perfect sense. Because the pears are grown in, the climate is right in Argentina, and then the workers are cheap in Thailand, and then in the United States they have the most money, so there they can consume it. But it's not alright, it's not the way things should be, and I think everybody kind of knows that. But the same thing in a way is going on with contemporary software development. So a lot of people, or a lot of developers nowadays, they already learn to work on a certain stack of technology, and it's not like a problem per se, but it becomes a problem if there are no developers left that actually can traverse the whole stack and actually understand what's going on. I think this is a screenshot from some web framework, and I think web development is really bad in that regard. And you can also already like feel like this is not okay. We should not like abstract to such a high level. And me as a developer, like in the before I started with NUP, I felt this as well. I don't like working on technology stacks that are really, really, really huge and complex. And we lose control as well, and knowledge. So yeah, then what is the right level of abstraction? Yeah, that's something we can discuss. And for me, it really feels like, okay, the moment you have no awareness of how your CPU works, that's kind of like for me the point that, okay, this is not going in the right direction. Maybe we should take a step back and actually think about what we're doing instead of just putting on another layer of abstraction. And of course, that's what's going to happen with AI as well. So in the future, we'll prompt our way to beautiful software. But I think that's bullshit. That's not going to happen. And you need people to really go down the pipe, know what's going on, and build software from that. Then again, I don't want to bash any framework, because I also see like when you use an engine like Unreal or Unity or use Touch Designer, it allows non-programmers to make stuff. 5 minutes? Okay, that's great. And I think that's that's a good thing. But at least you should be aware. You should be aware of the level you're working on. And for programmers nowadays, especially new programmers, I'm sorry to say it, but yeah, the level is just not there. And then people say, okay, but C and C++, it's so hard. You can do this much faster in Insert Framework. And I think, yeah, you can say that, but I think maybe some things are supposed to be hard. Like, I know it's an unpopular opinion, sorry. But if you want to make software at a certain level that performs at a certain way, you just need to go low. There's just no way around it. And of course, you can make beautiful software on existing technology stacks. But once you want real scalable software that runs on really tiny devices, up to render beasts, yeah, you need to know what you're doing. And it's okay, it's not for everyone. But I think as a developer, if you call yourself a developer, you should be able to traverse the stack and understand what's going on. So to summarize the problems of today, most programmers, they work on a very high level of abstraction. Hardware is just another API call, so we just have a huge data center in the cloud, and I need a new machine. I can just do an API call and have 2 more machines. We hide the memory management. Most programmers have no idea of how memory works anymore in a computer. It's just there, apparently. We have closed ecosystems and walled gardens, especially looking at Apple. Really, they're like, they used to be one of the good guys, but they're really not anymore. It's also, what I'd like to mention, we are completely cross-platform, but we deprecated Apple. And they actually sent us an email saying, hey, why do you don't support our platform anymore? And we kind of replied of like, if you are less shitty, then we will support you again. But we have not heard from Apple back again. So that's, I don't think they'll turn around. And you see what's happening with programmers as well. So you can become tied to an ecosystem. You become tied to, I don't know, Unreal and Unity. And you start being a paying member. And you're tied, yeah, you're bound to the ecosystem that they created for you. But also the blame is a little bit on the users of the software. So we are so used to bad software that we don't actually know anymore how good software is supposed to work. So yeah, and software decline is obscured by hardware improvements. So yeah, but software, yeah, it kind of runs as fast as 20 years ago, yeah, but it's supposed to run like orders of magnitude faster if you look at the hardware improvements. So yeah, these are the things that keep me awake at night. And thanks for listening to my worries. Yeah, so but luckily I also have a lot of inspiration. I take a lot of inspiration from the Team Human, from Douglas Rushkoff, who is also kind of like me, but a little bit older. He was really like a techno-optimist and kind of become more critical over time. And he has a really great podcast that you can check out. There's a really good talk about from Jonathan Blow called Preventing the Collapse of Civilization. Talking about the same things actually, but he does it way better. Casey Muratori is a really nice programmer. He has a course called Performance Aware Programming, and it really takes you back to how a CPU works, and really talks about programming and the internals of a computer. And it's designed for programmers that are not like taught. So if you're like a new programmer, it's also accessible for you. And then of course, heading for extinction, always nice to know the ecological predicament that we're in. It puts things in perspective. And there's a really great movie from Alexander de Oké. It's a game, it's called Elite. I don't know if anybody of you know it. It's a game from the 80s, and it runs on a BBC Micro. That was a computer built in the UK. But it's a procedural 3D space shooter, and at that time it just blew every existing game away. And it's really magical how they did it. It's really it's mind blowing how they managed to achieve making that game for the BBC Micro, and it's a really great documentary. So I would like to end with the final Dune quote from the Worm Emperor, and really. Would like to encourage you to check out NAP and see if you can get something running. And we seem like really grumpy nerds, but we're actually really friendly. So if you're on the website, just send us an email, and we're really open to help you out. Well, that's it.